designer specializing in colors, materials, and finishes. Let's give her a big round of applause to welcome her. Thank you very much. She is a part of the Wanted Design program, a program that brings in an artist to New York City for 2 months for a residency. And part of that residency is that they get to come here to the museum and work with us for a week. So during this residency, the artists that are welcomed to New York City and welcomed here to the museum, they get a chance to work with other materials that New York City and also the museum can offer to their recipients. And so we're very, very honored and excited to have Fanny here with us. And today what we're going to work on and kind of showcase what we've been working on are these beautiful bags. I'll go into them, and then the handles for the bags. I also want to introduce the team here. We have Chris Rochelle as the lead gaffer for our team for this whole week that Fanny is here. And then Helen Tegler is helping him out. I am Katie. If you have any questions at all, please let me know in-house and online too. You can post questions, and our lovely social media team will get that to me, and I'll answer those as they come in. So again, thanks for joining us. Here in-house, we have some of these beautiful bags that Fanny has brought that she's designed and created herself. So anyone here in-house is available to or is able to come down and look at some of these pieces, please do. They're pretty cool. But this bag in particular is really important to her work. All these bags are. They all have that kind of importance. But what we have here is leather. She's working a lot with leather these days. But she also, the strap is what we've been really analyzing and then recreating in our own glassy way. But the strap here, the plastic woven cover is part of, and is actually made by a manufacturer that makes chairs, that is making these chairs that are all over Paris. And so she's from Paris, and so she sees this and she wants to recreate that and give Paris a bit of a nod for this design. And then we have this wood that comes through as well. And the wood here goes all the way through. It's just one strand of wood is what she's told us. It's just elegantly bound by one strap. This wider part prevents it from slipping out. And it is really designed very minimalist and really sharply. So we're going to do that in a handle. And so we made this one yesterday. This one's very similar to what we're going to make, but we've kind of been looking at these pieces, and this actually fits nicely. And so this is what kind of the end result would be with that. It looks very nice, yeah? That will go on to the bag and can then be strapped in too. So this is kind of a way for us to play with that and see what glass can give us. All right, so to do that, the pieces that we made yesterday have this kind of solid bit. We're going to work instead by really, again, referencing this handle that has that loop. So the wider part, again, giving it the structure so it doesn't slip out of the clasp. And so Helen's going to, Chris made the loop. Helen's going to store that in our garage. Our garage is something that keeps the glass hot so that we can use the glass while not actively working on it. It's a place for us to put things away for a moment and then take it back out. So we're going to back way up and talk a little bit about glass and the process of glass making, and then, of course, get into what we're working on here. Inside of our oven, in the middle of the studio, is a 2,100-degree pot of glass, and that glass at that temperature moves like honey and it glows. So when we gather glass out of the oven, we're gathering it out on a stainless steel iron. So whether it's solid or hollow, it will, we can gather it up out of that oven. The tips of the pipes are preheated so the glass sticks to it, but that's our glass right there. It's yellow because it's hot, but it is clear glass. It moves like honey, so Chris won't stop turning or else it falls onto the floor. You can make things out of what falls onto the floor if you want, but you can also keep it turning and make something else. So he's going to start the rope part of this piece, and we've done a lot of experimenting with this part, and what we've really landed on is an optic twisted rope. We're, again, referencing the woven parts via the chairs there in Paris, and so we're going for that rope-like look. So there's our first gather. We can't get all the glass that we need with just one gather of glass because of the viscosity of the material. So we're just going to get a little bit, let it set up, go back into the furnace and gather again. And then Helen's they're gonna chat often about the process. I'll jump in. We did a lot of these, and I was kind of, we all fill into those little roles, so I know I'm gonna help out as we go back into the furnace to gather another time. Any questions so far in our audience online? Just checking in. Okay, all good. So there's our second gather. I think we'll get one more. And then to get that optic pattern, we're going to put the glass into a mold called the optic mold. And that will give us some lines on the piece, some thick and thin areas. Chris cooled the pipe briefly, returns to the workbench, and he'll start to cool and shape the material with a wooden scoop tool called a block. And while he does this setup, I'm just going to kind of talk a little bit more about Fanny. She is a product designer specializing in colors, materials, and finishes, CMF design. And her career integrates several areas of interest that have shaped her professional journey. Industrial design, a love for well-crafted and carefully drawn objects, artisanal craftsmanship, and manufacturing processes. She has collaborated with various industries, including automotive, electronics, and luxury goods, while cultivating a materials-focused approach to design and production. In 2022, she launched L'Eclisse, a brand where unique savoir-faire and leatherwork converge. Each piece is designed to really stand out on their own as like a really kind of statement accessory. And this blends her expertise in CMF design with distinctive manufacturing techniques and lesser-known craftsmanship. And L'Eclisse is inspired by a range of fields, including object design, architecture, and the decorative arts, with a focus on transitioning from object design to fashion accessories. And so check out her website. She's got a few references over on our whiteboard. Her website for L'Eclisse is L'Eclisse, Leclisse-Paris.com. So check that out. Really wonderful things that she's been up to and producing. All right, so we've got, oh, cool, look at this, going into our mold. He'll press it into this mold. He gets that beautiful optic design, and then we'll start to shape this. So I'll jump in a little bit. So we aren't going to gather over it. This will be plenty. To make this into that rope, we really want to pull this and twist it at the same time. And so this is a part where there's going to be a lot of fast moving because the glass is moving quickly. So pull and twist at the same time. He holds it up like this to allow the tip to retract a little bit. If it gets a little bit larger, that thins it out. So it sends the bulk of the glass down. So think of what gravity's doing here. And then when he holds it that way, it goes the opposite. Really twisting that up. He wants an even, completely even pull where the left side is going to be as thin as the right side. And that's how you would do that to get it to be that same length as that up and down sort of juggle. Then we have a mold. I shouldn't say mold. It's a drawing on a kiln shelf that we're using to get that curve for the piece. Now, when it comes to having a piece of glass that needs to be connected, we have a height that we want for functionality, but it also needs to be the same width as the bag. So not only do you have to have an arch that's perfectly round here, but also these two sides need to get down to that measurement. And that's tricky. Chrissy's using that hot torch to heat a little extra. That's kind of a auxiliary torch. They can use that torch to heat particular areas. The reheating chamber is an all-over and all-encompassing heat. The torches are going to be particular area of heat. So this torch is a 4,000 degree torch that quickly heats the glass and melts the area that he wants to change. Right now, he wants to create a line where we're going to remove the piece from that pipe. So he heats that area. You can see it's moving just in that one location. And he'll make that constriction line. The glass has cooled quite a bit. You can see the clearness coming through. So this is colorless glass. All right, so we've got a great curve. We're going to refine that curve quite a bit. But right now, we're going to take it off of the pipe it's on now. And so we're going to add a puntee to it, which is just a little bit of glass on the end of an iron. This one is a particularly important puntee. We want the tip to be really hot when it goes on, so we have a nice structurally sound connection. And then we're going to leave that part of the puntee on the piece. It's called a sculpture puntee. So when Helen cools it, she'll cool the backside, but leave the tip hot. All right. So Chris is adding just more heat as we go, keeping everything nice and warm. And now he squares it up, make sure that we're on center there. And then he attaches that puntee. So again, that's a really nice, good, hot connection. And now we're going to get the glass to break from the pipe. So we don't really ever want to cut the glass. We actually want to just break it. He cools it, and then a nice tap breaks that glass free. Transferred successfully. Let's give him a big round of applause for that. That's pretty fun when that goes well. With this team, all goes well. All right, so now we're going to focus on getting that arch perfect. All right, more heat on the tips. And then we're going to remove some material. That's pretty tall. And Fanny liked the shortness of that. I agree. I think this shortness really looks great. It's with wood and the plastic pattern, it's different. With that glass, it's nice. If it's thicker, of course, too, to have that a little smaller. Great perspective. So once that suction gets warmer, it gets more pliable. We can break that free. When Helen goes into the oven, she's briefly heating this. You don't want to overheat this right now, or else the whole thing is going to move. We're going to get that nice arch. You know, we'll change the arch in a negative way, which we'll do in a little bit. But right now, we want to focus on the length. So short reheats. If the glass gets too cold, it will crack and break. So we have to always monitor the temperature of the glass. We don't have any readouts or ways to know for sure the temperature. So we're guessing. But with 30 years of guessing, they get pretty good at it. So we read that mostly using our experience. Also, movement's a good indicator. When we're looking at the glass, you see Helen stops every once in a while. She'll twist and then stop. But we're looking at that movement. Color is not a really reliable way of telling that the glass, what the glass's temperature is, especially with clear glass. If it's not yellow, then it could be anywhere between 1,800 degrees and room temperature. So it's really not a great sign to look at or analyze. Some glass color, like cobalt blue, really shows off where the temperature is when you're working with it. It's still not overly reliable because it still could mean it's not as hot as you think. So this kiln plate that we keep taking out and putting in has the drawing on it. And if we keep that kiln plate really warm, when we use it against that, when we use the rope against it, the rope won't get too cold. That's another way for us to monitor the temperature of the glass, is to keep our tools hot. So we had that plate in the annealer. The annealing oven's job is to slowly cool the glass down to room temperature. If you leave glass out at room temperature to cool, it'll cool down within about 30 minutes or so, but it will crack and break on its way down. So instead, we put it into the oven to slowly cool. Every piece of glass in our lives has gone through that slow cooling process. You can't have a piece without cracks without it. Some pieces, you know, if they're extra thin or whatever, you know, there's still going to be stress built if it's not slowly cooled. So Chris is now checking that arch. He's using a pair of cork paddles, or I guess one cork paddle there. Cork handled paddle there, and looking at that, that's kind of subtly nudging it into place. He's also using a pair of tweezers. Right now he's adding some heat in one area, and then he's making a few notches. This is, again, where we're going to shorten the handle a little bit more. Oh, and I mentioned earlier, you saw him in the very beginning of the demonstration make the loops. The loops are going to be added on to that section, too. That's what we're going to do in the first half, I believe, or more of the demonstration. And then we've been working on these pocket mirrors in the shape of a kind of a donut is what we're calling them. So we'll talk about that when we get there, but that's going to be part 2. So once again, Chris will superheat that area, and then we'll remove that extra material. Chris is being careful when he cuts and removes that extra glass to not cut it when it's on the tall side, because if that happens, it'll fall onto the other one, and then it'll be stuck there. So there's really small nuances when it comes to glass making to be successful. Lots of experience is needed. But it's fun the whole way. So if anyone ever has a chance to blow glass or make things with glass, I highly recommend it. Here at the museum, we have a make-your-own program next door at the studio. And you can be aided by a professional and kind of dip your toe in the glass-making experience. I recommend that as well. It's very fun. They teach classes next door at the studio. And on our YouTube channel, we have extensive videos of glass making, so you can always tune into what we're doing here. And check out our newest videos, so this will be one of them. Little refining movements, one by one. This is how precision glass pieces are made, precise glass pieces. And let me know if there are any questions for Fanny. We can answer them for you as well. All these little bits of clear glass can be recycled. Our furnace upstairs in the innovation stage, which you can check out at Hot Glass Show today, up there. All of the glass that's in that furnace is recycled from down here. So we recycle in-house, rely on that. And again, this is clear glass. We'll talk about color when we work on our other one. Our other piece, we can talk about it now actually, but to get glass color into glass, we buy glass color pre-made by a manufacturer. And it looks like this stuff here called frit. This is little granules of crushed up glass color. This will stick onto the surface of a fresh gather of glass, so it's when you want to add it in the very beginning.
We're ready to do the loop.
Okay, yes. So, we didn't do that on this one. We'll do some glass, we'll add some glass color on the next one. There are many forms of glass color. All right, I'm gonna jump in. You'll hear little mm-hms as we go. We're going to add the loops. The loops, like I mentioned, are pre-made. They're in the garage. Helen's going to heat them up and bring them over. By heat them up, I mean she's going to get them ready to be out in room temperature. The garage temperature is around 1,000 degrees or so. It's close. It's hotter closer to the flame, which is on one side of the oven. And the closer we get to the flame, the hotter the glass gets, and the hotter it gets before it comes out of the oven into room temperature, and then into a 2,000 degree oven to be prepped to be added to the piece, the better. So that's what Helen's going to mostly work on. Is prepare that, and I'm going to help out. Here comes the loop. I'll bring it over. He'll hot torch the connection and the loop connection, and then he'll add that together. So the hotter that connection is, the better the weld is, or the fuse. And he gets it nice and centered. This connection point is still moving a bit. This is the time to adjust it. He uses those cork paddles again. The softness of the paddles is helpful. It's also not a cold tool to use. Metal would be a cold tool against the glass, okay? And cork doesn't really transfer a lot of coldness to it, so it works well at this instance. So just minor adjustments. Now it's time to add the next one. Same thing.
All right, Helen, go ahead. Stay right there, Kate.
So again, heating that area. Helen goes into the reheating chamber over there. And then we come together. They break that connection, and now we'll attach it. So again, judging by the movement, you can see how hot that connection is as it moves back and forth. Mm-hmm. Mm-hmm. Thank you. All right, we're going to add a little heat to the colder parts, and then Chris is going to just refine that.
I'm gonna make just a couple little adjustments.
Okay.
Go ahead and take a heat to fluffy torch right now in the back, and then I'll do my cooking.
Okay.
Shot sideways. I'm gonna fluffy torch close to where the contacts are a little bit. We're gonna take a nice flash, and I just want to squeeze it in a ton.
Okay. All right, a few more refining moments. Just really want to get those dimensions, because once you make something, you can, you could reheat it and change the shape with something like this, but like a blown object that's thinner and has a lot of maybe components or details, it's much, much more difficult. Even picking something like this up, again, like I mentioned, you can't just heat things quickly or cool things quickly, so heating something like this back up again and trying to change the shape could cause a lot of problems. You could break it. So it's good to be precise the first time, or try to at least. Okay. So using calipers to measure the width of the purse, that was for the very bottom of the purse. If you look at the side of the purse, they match. Yeah. All right, everything looks good. Cool. Okay. Okay. All right, so now we're going to take this off. We're going to work on taking it off of the pipe and putting it into the oven. So Chris likes where everything is, looks good. The caliper measurements look good. So that punchy connection is very strong. We're going to melt that down a little, make a section where we can break it off easily. We call that a neckline or a break line. In many different ways you can call it. And then we'll put it into the oven. And then we'll start on part 2. So the hotter this connection gets, it gets a little bit squirrely. But we'll deaden that heat just slightly, making that groove. And then we'll put it away. Helen's going to put this into a 960-degree kiln, and she's going to do that using Kevlar gloves and a face shield. The Kevlar gloves protect her hand so she can carry the object. It's going to be around 1,000 degrees when we put it into the oven. And the face shield protects her eyebrows and her face from the 900-degree oven. We're going to safely put this way into the oven. So he'll crimp that section. Helen's going to stay under it, so if it does come off early, look at this, a light tap breaks it free. Lovely. Let's put it away into the oven for slow cooling. We'll see that beautiful piece tomorrow. Let's get a big round of applause for the team. Lovely. Well done. All right. That's our bag handle. That part's finished. We're now going to switch gears and work on a pocket mirror. And I'll explain some of these objects to you. So we have some of these things here that we've been working on. One of her designs was to create a pocket mirror where the glass is the center. It's the mirror. That's what a mirror is. And you can kind of hold on to it with the leather. So this is one of the ones that we've made here. We're going to add color to it to mirrorize it. Mirrorizing glass actually has a lot to do with adding a chemical compound when the glass is cold. And instead, we're going to do it hot. So we experimented with a few different colors. To add the color onto this, we're using mostly powder as the material, the glass color method that we're using. And the types of colors that we're using reduce. And that means that the metals that are in the color will rise to the surface, making it mirror-like, making it metallic. To make glass color, you add a metal oxide into the material. So this color that we've really settled on is silver blue. And you can see yourself in this reflection. So that's the silver that's risen to the surface to give us that texture, that mirror. That's what we'll do. Precisely, we're going to do the donut shape. So the donut is a really technical, turns out, piece to make for us here for this one. And it's pretty fun to watch. So we're going to make a donut out of glass. We're going to sprinkle some powder onto the surface, then mirrorize it. And our prep is going to begin with this tiny 3-prong punty. It's itty bitty. The punty is the connecting iron, so we can take the piece off of its original iron. And this one is 3 different connections so that we can connect to the hole, the part of the donut here. So we're going to have 1, 2, and 3 connections on the back so that usually we connect the punty to the middle of the back of the thing. But this is going to be small, and we're going to try to get it kind of inside of that opening, inside of the middle of the opening. It's proved successful for us in the past. And so Helen's going to pre-make that so that when we're ready for it, it can just be brought right out and put right on. Heated and then put right back on. So that's something that we'll put back into the oven to keep hot, our garage. Any questions so far? No problem. We're going to make a different punty. Same thing, just different. Make another one. We have a few other projects that we've been working on. Today we rolled up a really elaborate cane pattern. There's some of it over here, which in-house you can come check it out. But it's a cane pattern using strips of glass, which is cane, and then cut in a particular pattern, fused together, but this isn't something that we can inflate like normally a cane pattern would be fused together to become the walls of the bubble. But instead we left some gaps to really mimic the kind of basket-like weaving of this pattern that we see in this bag. And so we just started that today. We did one earlier, and it's in the annealing oven for us to see tomorrow. We have another pattern ready to go. We're going to probably work on that tomorrow morning. So it's really nice to have artists come into our space here, be able to facilitate whatever they want and whatever they see in their creative minds, and then to be able to make it with them, and we learn and they learn. It's a lot of fun. It's a great collaborative effort here at the museum. I'm very proud of that. To get glass into our furnace, we pour in little, actually it's not little stuff. This is batch. This is the raw ingredients of glass. It looks like this. And the glass company that we get our glass from is called Glasma. They're actually sponsoring this event. Very excited about that. So batch from Glasma, we pour it into the furnace. This is not glass. When it melts, it turns into glass. That batch is pelletized. It's a really great material. And the glass is great. We love it. If you add a metal oxide to that batch, you get a different color. We have a little tank over here full of cobalt blue that we're using. We're going to use that throughout the year. And so we took the batch from Glasma and we added some metal oxides. This is what a metal oxide looks like. This is actually essentially iron oxide, which is essentially rust. This makes green. To make blue, you would use cobalt oxide. You could also use copper oxide. Any metals you can think of will make a glass color. There's a close-up of our 3-prong punny. And we'll put this one away into the oven. I think this is the one we'll use. All right, now we'll get started on the donut. So this is a blown object. So we start with a blow pipe. This pipe is hollow. The tip has been preheated. So, of course, the glass sticks to it, like mentioned before. And I think this will be enough. We won't go get another gather of glass. They're not extremely thin, but they are handheld. They're small, relatively speaking. This is something that, an accessory that you can have in your bag. And she wants to bind, kind of surround it in leather. This is the closest kind of finished piece that we have for that. This one is on a really amazing leather string. So this is that same sort of thing. It's going to be attached to the bag. This one will have maybe a hole punch and then attached. So you can kind of, use it as your accessory. Some of these, this one, we have a little bit of a ridge where she can make that leather connect to the glass. You can't really fuse glass and leather because the leather will catch on fire. You can do it in other ways. This is a great way to do it. Oh yeah, we can wrap that string around it too. That's awesome. So Fanny has brought lots of materials to work with. She's got some leather to work with. It's really been fun to have her here. Lots of great ideas. He blows into the pipe, expands the bubble. That will give us more volume. This is the disconnection point, the neckline. He'll inflate that. And again, we've had lots of practice with this form. We've figured out what works, what doesn't work. And poking the hole is done a little differently than, I wouldn't say, maybe I would say traditionally done in the glass technique, any specific technique, but we basically want to remove any of the area for the where the pipe connects to the piece, the break-off point. We don't want that to show. We want it to be in the back where it's going to be covered up. This piece that has that, oh yeah, this one that had the string coming from it, she puts a little piece of leather in the back. So we're actually hiding the hole a little. And we can try to do that with the glass too. We flatten the donut slightly just by holding it up towards the ceiling. When he did that, he trapped the air with his palm so that the air didn't deflate the bubble. The air can come back out the other end of the pipe. It's not hot when that happens. It's room temperature. But we keep it there, allowing the bubble instead to widen slightly with the palm of our hand. So we cap the end of the pipe when we hold it up like that to squat the form. Glass is highly influenced by gravity. If you get a gather of glass from the furnace, it's moving quite a bit straight from the furnace, and you stop turning the pipe, the glass falls. But we can use it as a tool. And Chris does that here again, holding it up, capping the pipe, squatting that form. He'll squeeze that line a little tighter. The tool he's using there is called a pair of jacks. Very necessary tool. The jacks are made of stainless steel, and the blades are lined with beeswax. So you might have seen a little fire coming from that tool just a minute ago. Just add some drama. So the beeswax catches on fire as we use it sometimes. Melts away quickly, but it's necessary also for that tool. He'll now take this kind of metal spoke and then press it into the center. This allows us to have a really clean donut roundness for the center. And then we've been working on particularly different widenesses of that internal opening. So this one's a lot wider here. And then these are a bit smaller. So he opens that further. I just heard him say he's going to let that set up, so the front set up, which means we'll add a little extra heat to the back, equalize the temperature slightly. When we close off the hole, when we break it off the pipe and close off the hole, we close off the bubble. When you close off the bubble and you reheat it and keep sculpting the material, the air inside will expand as it gets hot. And so we did that before. This one's closed off. And you can see this little area, this blemish here, is from when it expanded in one area and then it deflated a little in that area. And that's because it was closed off. So we can't really close it off and continue to work with it. So we put a little hole in it. That's what he just did. He dremeled a little hole. Not dremeled. He tungsten rod drilled a hole into the side. And if we do it in a particular area on the inside, like I mentioned, all that we can cover up with the little leather hole there. And then here comes the 3-prong punty from the oven, brought over. And they'll attach it right to the center of that donut. It's wide. We want those prong punties to also be wide so they attach, they make it. There's ways to widen it still, so if it does need to be widened, it can happen. And this is still clear glass. We'll add the color on at the very end when it's all finished. They're going to trade off crystal, make sure that opening is accurate. Helen goes into the oven just to keep that piece from getting too cold. We do want it to break right along that constriction line near the pipe. I'll do that shortly. And here we go. She brings it over, he'll attach it. Nice. And now we'll get the glass to break from the pipe. A drop of water will do the trick to thermally shock it, and then a light tap breaks it off. And then we're on the other side. So now we want to push that hole, that opening, into the body of the other part that we pressed in. So kind of marry it there and then remove that material to make the hole. Now the type of glass that we work with here in this hot glass studio, and many hot glass studios around the world, is soda lime glass. There are many different types of glasses. This is the more common one. Even our factory-made, manufactured glass is soda lime too. To make soda lime glass, you need 3 major ingredients. The first one is silica sand. Silica sand is not the type of sand that you get from the beach. If you get sand from the beach, it'll be full of, it's mostly made of sediment that's been washed outward from inland. It's been washed onto the beach, into the water as those rivers make deposit into the ocean. So it's mostly sediment. It has organic matter in it. It has seashells in it, and sometimes trash, all kinds of different things in it. But the silica sand that we put in our glass, that is put in soda lime glass, is mined out of the Earth's crust, and so that's where you find silica deposits, a very pure, kind of pure sand that's then refined. To that mixture, soda ash is added, and soda ash is the flux. It lowers the melting point of the material. Then limestone stabilizes it. The glass that we work with here is made a little differently so that we have more working time with the material. Machines can make things a lot faster than humans can. And so the formula for that is usually it sets up faster. So we have a longer working time here in these studios, and in our factory settings, the glass sets up quicker. So you can make more objects quickly. So you can change and manipulate the material every once in a while to get a glass that maybe forms differently. Another glass that's similar to this glass is lead crystal, which is made with lead oxide as the flux instead of the soda ash. But a very similar process. Lead crystal is made in this same way if it's handmade. It's just softer, so it's usually used for cut crystal objects. So Chris has connected that hole together. So now we have a flat face, which now he can use to press inward to meet the middle, which it already looks like it's very close. That might have done it right there, that using gravity on the way over. Yeah, he's doing that purposefully. Again, using gravity to do so. And then he can sculpt that side as we go. We're going to make another tungsten hole. This first one might have melted together. Lots of trial and error with these precise pieces. That's what's so fun about working with designers, is can we do it? And let's try. So that's a tungsten rod, and he heats the tungsten rod. When it gets hot, the tungsten rod will move through the glass, and the glass won't move. It'll move away from the rod. But that's how we get a precise hole. And actually, he did that on purpose to open up the donut hole. The other one that we had as a vent is fine. So that was my bad. Misspoke. So that's a way for us to open that one section. And then we'll spread that glass apart. We really need a lot of heat here to get that part of the glass to melt back into the donut. This is definitely not a piece that could be made without a torch. The torch being used in a hot shop is relatively new. Glass blowing's been around for 2,000 years. They definitely didn't have torches back then. So what we can do with glass these days is definitely broadened by the use of us being able to use that torch, in in the hot shop. You can make very, very precise objects, very lifelike objects. We can work with color differently. We can make glass a little thinner as far as additive bits go sometimes with sculpture, etc. So you can see him really pushing the walls of that glass up with the blades of the jacks, the very tips. And then he doesn't want it to come out the other side, so he's watching that there, pushing that back with the tweezers where he can. That 3-prong punny is in the way a little, but that's really the only way to punchy this piece if we want that hull to be symmetrical. And then the color we have out, we have the glass powder that we're going to sift onto the surface. It's that silver blue again. In our powder booth over here, glass powder is not healthy for your lungs, for your respiratory system. So we have it in a powder booth tucked away. That powder booth has a ventilation system, very unique, very well engineered. And we can sift powder onto the surface and not have to worry about it becoming an issue for our lungs. So now pulling that open with the jacks. It's not an easy task, this piece, but it's been fun. All right, we're going to add on our powder. Chris is lightly heating the outside. That's where we want the powder to adhere. We're just going to do the top side. The back side is left to be clear. It also has a really beautiful gradient transition from clear to color. The way the powder falls onto the glass, it creates that gradient. And also texture, because we don't really purposefully melt that side in, just the top to get it shiny, more reflective. So here they go. They're going to sift that on. Chris comes over to the powder booth. Helen gives it just one last little heat, and then they're going to sift that on. You can hear him tapping in the sifter. There you go. Great camera work. So you can see that gradient on the side going on. It's blue powder. It's silver blue. But when we reduce it and bring those metals to the surface, it turns silver. And then to our oven to melt that layer in. We've been adding 2 layers. 2 layers seems to be enough. They'll melt it in. It'll be blue, which is beautiful too. Oh. Good question. The question, just so I could reiterate for those online, is do these ovens have different temperatures for different purposes, or are they all similar? They're kind of similar. Some of them do have different purposes. The reheating chamber and this reheating chamber over here, we have 2 different reheating chambers. One is to work out of primarily. The second one is what we're calling the assistance bench. It's just an extra auxiliary reheating chamber, but same temperature, same purpose. The garage over there has one purpose, which is you can park things to use later. And so that's a lower temperature to where the things in there don't move. It's not hot enough for them to move. And the hotter side is so we can get things happier before it goes into the 2,000-degree oven. But generally, that's mostly it. We have a pipe warmer to heat the pipes of the tips of the pipes that then allows us to stick the glass onto the tips. But yeah, a few different uses, definitely. Yeah, good question. All right, so we melted in the powder, and Fanny is the one making the calls. Chris is making it, but Fanny says, okay, more, okay, less. Ooh, I like this, or can we do, more reduction? She likes this. It's a very delicately shiny blue, but I think they're going to add a little bit more reduction. We'll see. I'm going to stand by the oven because that's the next step after this. Is to put it into the oven to slowly cool, but we'll see. Here comes the reduction. Just a very light little bit of that high gas flame brings the metals to the surface, and it becomes immediately shiny. It's so fun to watch. Okay. Into our oven it will go. We'll add a few drops of water to those small ankles of the 3-prong punty, and a light tap breaks it off, and away into our oven it will go. After about 12 hours of slow cooling, we'll be able to see that piece. And let's get a big round of applause going for Fanny, everyone, and the team, Chris and Helen. Thank you all so much for joining us today. That will do it for us. Yeah, thank you. I want to thank our team, Fanny, of course, and Helen and Chris. I also want to thank